Hello and welcome back. Today we're going to talk about graphs and how they're used within kinematics. Now, we've gone over several different relationships between position, velocity, acceleration, and time, and we've formulated equations using it. Now, here comes a funky question. What if we graphed these equations? Well, let's see. Let's start with the position-time graph. On this graph, the x-axis is time and the y-axis is position, with 0 being where the object started. This graph actually tells us a lot about the object's movement. For example, we can trace the object's path. If we treat right as positive and left at negative, it started at 0 meters, and then over 10 seconds, it moved to the left 5 meters. As you can see by it going into the -5 position. So, this highlighted section of the graph is the object going left 5 meters over 10 seconds. In the next 5 seconds, this object moves a total of 15 meters to the right. Now, where did I get that 15 meters from? Well, in this section, it is still going right because it's moving in the positive direction, and it goes from that -5 position back to 0, which means in this green section, it traveled 5 meters. But then it keeps going and reaches +10, which means it moved a total of 15 meters within this 5-second range of 10 to 15. In the next 5 seconds, this object moves left 10 meters. You can tell that because it goes from the +10 position back to the 0 position, which means it must have moved left 10 meters. And then for the next 5 seconds, the object remains at rest. Let's summarize quickly the path this object traveled. From 0 seconds to 10 seconds, the object moved left a total of 5 meters. From 10 seconds to 15 seconds, the object moved right a total of 15 meters. From 15 seconds to 20 seconds, the object moved left 10 meters. And from 20 seconds to 25 seconds, the object stayed at rest. It's pretty cool how we can follow the trail of an object by using a position time graph. But what else can we do? Well, it turns out we can find average velocity through this graph. If you recall, average velocity is equal to displacement over change in time. If we use this equation with the information provided on the graph, we can find the average velocity over intervals of time. For example, from 0 to 10 seconds, our displacement will be -5 meters minus 0 meters. If you remember, displacement is final position minus initial position. The change in time will be 10 seconds minus 0 seconds. Final time minus initial time. This simplifies into -5 over 10 seconds, which eventually will simplify into -1/2 meters per second. This gives us our average velocity over the time interval 0 seconds to 10 seconds. Our velocity is negative here, which means this object was moving left at a speed of 1/2 meters per second during this time interval. Let's try 10 seconds to 15 seconds. Our displacement is going to be 10 meters minus -5 meters, and our change in time is going to be 15 seconds minus 10 seconds. This will simplify into 15 meters over 5 seconds, which then simplifies into 3 meters per second. Since this velocity is positive, the object is moving right at a speed of 3 meters per second during this time interval. This is how you can find average velocity from a position time graph. Now, I'd like to point out something really important. Notice that when I was calculating average velocity, I was, in essence, calculating rise over run. And if that sounds familiar, that's because rise over run is the slope of the graph. What does this mean? Well, this means the slope of the position time graph is velocity. Let me write that down. Slope of xt graph is velocity. That's something really important you're going to want to remember. And given previous information that velocity is simply the derivative in terms of time of position, this makes complete sense because the slope of a graph is, in essence, its derivative. So, taking the derivative of a position time graph will give you velocity. To end this velocity section, let's find the average speed of this entire journey. For this, we'll put the total distance traveled in the numerator and the change in time in the denominator. The total distance traveled will be 5 meters from 0 to 10 seconds, 15 meters from 10 to 15 seconds, and then 10 meters from 15 to 20 seconds. There's no movement during 20 to 25 seconds, so we can disregard that in the numerator. We cannot disregard that in the denominator, though. Our change in time is going to be 25 seconds minus 0 seconds. This simplifies into 30 meters over 25 seconds, which turns into 1.2 meters per second. So, our average velocity of the whole journey is going to be 1.2 meters per second. I hope you enjoyed this introduction into the position time graph. Thank you for watching and happy learning.